Okay, so welcome everybody. We are here on the third day of this EuroPython 2K12. I have an announcement. We already have some videos from the past days ready. So if you connect to our network, you can find them at the address files.ep. So it's files.ep, which stands for EuroPython. Okay. Yep. Yes, please, quickly. Thank you. Okay, we are here with David Cramer. He works for Disqus. He has already presented some talks at EuroPython 2K10 and last talk, I think.
Yeah, I gave 2 talks last year.
Yeah, 2 talks. And he's here today to show us some lessons in testing. David, the show is yours.
Okay, great. Hopefully everybody's a little bit more awake this morning. So I'm going to talk about lessons in testing. This is kind of a lengthy talk. We'll see how it goes. I have quite a few slides. I'm going to try to go through them somewhat quick, but slow enough that everybody can understand me. Most of this is a lot of stuff we've learned like through the history of Disqus. When I joined 2 years ago, we had kind of an iffy test infrastructure, and it's become much better. We've come a long ways. So who am I? I work for a company called Disqus. I actually lead infrastructure at Disqus. Infrastructure to us means everything that keeps everything online. So Disqus is a commenting widget, is our main product. It kind of looks like this. So I do everything that you don't see, which also is a lot of our testing infrastructure, our SQL stuff, everything in between. So Disqus is a very big Python application. These are actually new stats that we're releasing today. We're about to hit 800 million unique visitors across the network, about 5 billion page views, and this is about 30 days of data. We also use Django. We are, I believe, still the largest consumer of Django, as well as the largest consumer of Flask. There's also going to be another talk, I believe, tomorrow, which talks about one of our core products that's powered off of Flask. We're also a growing startup. We only have we have actually 17 engineers, I believe, and a couple interns. Nice group photo we took the other day, about 40 employees right now, just moving to a new, bigger space. And we are also terrible at testing, but we're trying very hard not to be. So this presentation comes down to lessons we've learned and kind of our high-level aspirations of where we want to go with things and what we believe in. So we're going to start with lessons, sort of lessons. And lesson number 1 is nobody really wants to write the tests. You just want your code to work and magic to happen. I also like to say tests suck. Writing them sucks. And there's many reasons for that. The first reason I'd like to cover is they're time-consuming to write. Very, very time-consuming sometimes. It can take up half of my day easily just writing tests. And to give you an example, this is actually sort of something we wrote the other day. It's a simple Django middleware which handles before it hits your end view. So you can do like random logic on whatever you want. And in this case, we're changing some state in the database. So it's about 10 lines of code without white space. It's not overly complicated. But when we test it, we need to test many different aspects of this. So we try very hard to write fast tests. We don't succeed usually. But an example test for this looks something like this. So it's a very precise test. So in this case, we want to know like when the request is a post request, do we enter transaction management, which we're actually using a mock library to do this, which is an amazing library. And we're just asserting that the function's called. Now, even if we do something this way, this is more or less a unit test. We still end up with quite a few tests, enough that you can't see them on the screen. It's about 36 lines of tests, which is almost 4 times the amount of code. And this may not even be 100% coverage for like the basic behavior. So in this case, actually I think this case it was like 75% of the time was me writing tests, like digging into the internal APIs of transactions and making sure whatever I was testing was correct. And like even in the worst case, we usually spend about half the day writing tests. And this is like not terrible with new code. That was entirely new code. We are able to test it up front. The tests are very concise. They describe exactly what they're doing. Unfortunately, we also have a lot of legacy code, as do many projects. Especially with startups, you generally release first and test later once you have more time. And it turns out that's very expensive, not just for the time it takes to come back and test it later, but whenever somebody has to learn that system and they're going in and they're trying to change it, they have to actually go in and understand the whole thing so they can write tests. So a few things we've tried to follow with all of this. First and foremost, we always add tests for new code. Any kind of new code, we require tests. We always add tests for regressions. So if there's a bug on the website and it was simply that maybe this kind of data was never seen before, we make sure there's a test that covers that so it can't happen in the future. And these become easier and easier as you already have existing tests which kind of test the same behavior. You can just abstract pieces of that out, and it comes down to just a few minutes to add a regression test sometimes. And in that case, it could be 10% of the times adding the test, 90% of the times reproducing the bug, and then actually fixing it. So one of the other big issues is that it's slow or inaccurate rather. And in our cases, you only get to choose one of those. And it comes down to this. You can spend more time writing tests, or you can spend more time running the tests. And we've kind of chosen to spend more time running them. And we've optimized to make this better. But what this means is that we're writing much higher level tests, much more integration, less unit. And they're CPUs are pretty good at this point. This is what it really comes down to. Hardware is cheaper, and it keeps going down in cost, and engineers keep going up in cost. So the time to run is much better for us. And there's many ways you can make it faster and faster without actually changing anything in your test suite. One of the other problems is when we're doing low-level testing, like the example I showed, is we're relying on interface contracts, which can be inaccurate if you're not testing your own your own code. In that case, we were testing something within Django, so when we upgrade Django, maybe all of that breaks. We don't actually know. There's documentation behind the interfaces, and we're relying on it being that way. But let's just say 50% of our tests, we're relying on the interface being that way, and now there's a backwards compatible change. Because we did such low-level tests, we now have to go back and change every test to match this new behavior. And a few highlights with this. For example here, we're mocking, this is shortened, but we're mocking literally this function, and we're making sure it's called with this value. So first and foremost, is that how we should call enter transaction management? Hopefully. Hopefully it doesn't change. It probably won't change, but we can't guarantee that because it's not our API. And another line in there was we're calling process view, which is a function that executes right before your endpoint executes. And in this case, we're actually not passing all the arguments of process view. So our test is only semi-correct because there's actually 3 additional arguments that will be passed to this. So in our case, we know that they are, and we're just catching them all with star quarks. And it's okay because we understand that. But if somebody wasn't familiar with Django and they went in and they started writing tests like this and they assumed that, oh, I just need this request argument, now nothing's going to actually work in when you get it beyond the unit testing stage. And it goes back to these are uncontrolled interfaces. You don't know how they're going to change or what's going to change with them. And a good way to deal with these kind of problems is changing things to integration tests. They're not that much slower in many situations, and you can optimize to make them much faster. So in this case, we were actually testing a couple things that we weren't before. So we've changed all of that code that was mocking the transactions, and we're just using Django's test client to post to a base URL, which we assume exists. And we've added a little helper here called assert in transaction that's just guaranteeing it enters transaction management. And we've got one other thing in the setup that's more or less a functional test that's saying, oh, we need to ensure that this middleware is installed. Because if it's not installed, it doesn't matter how many tests you have, it's not going to work. And that comes down to more project tests versus library tests, because you generally don't care if your library is installed as long as it's working. So the higher level tests are going to be slower, but they're more correct, they're much easier to write, they're much easier to understand. And there's really no right way. That's what it comes down to. So it comes down to unit integration for most of us. There are many other testing styles. There's functional. We have kind of high-level smoke tests that kind of involve that, those attributes. And they work fairly well, but the trade-off is that they're exponentially slower compared to simple integration tests. So this, again, this is the unit test. We're literally just testing, was this method called with the right parameter under this request? Very concise. It will almost always work. Unless things change. And compare that to the integration tests, which is much easier to see what's going on. Obviously, there's code that we've written in this assert in transaction, but that code's reusable. So anything that ever needs to test transactions can simply go in and do this. And that means we had I think there were 4 of these in that example. So imagine like 4 of these tests that are literally like, oh, this is a post request, this is a GET request, maybe there's a few things that change in there. They all become something simple like this 2-liner here. And which is better between these? Like really, we rely on both of them. We have about 95% integration tests, and I think our test suite is between 1,500 and 2,000 tests right now. The unit tests run in a few seconds. The integration tests on a new machine run in 5 minutes, which isn't terrible for an entire test suite, which powers a large majority of Disqus. One of the other things we were using a lot in here is mocking, right? And mocking is great. It's very nice to test certain behaviors, which I'll talk about more in a minute. But it's very fragile. Like as I said, like the path can change, and you have to change how you're mocking it. The function calls can change, and you have to change how you're mocking it. Like every little change that you make in that code will require you to update how you're testing that if you're relying on mocks and unit testing. So we go back to that example. If the path changes, like this is no longer valid, you have to change where you're patching, which isn't that bad unless this is scattered throughout your code base. And if the arguments change, you have to change this function as well. And there are other ways you can run these asserts on here. There's many different methods that you can say, was it called with these set of arguments? Unfortunately, that takes much longer to write, and then it goes back to, do you want to spend more time writing your tests or more time running the tests? It's very, very useful for testing external services. We use it for mocking Twitter, Facebook, Blogger, pretty much anything that connects to any external API, even internal APIs, we will mock. And it's not too bad. It takes a little bit of wrapping your head around. I have an example later of how you can do things like this. But it's very, very nice because it's very fast. You're no longer relying on the service being online. Because if you are testing things like Twitter and Facebook, you'll routinely see your suite fail just because one of those services isn't responding. And with this, like, it comes down to limiting what you test. Like if we're mocking the Twitter API, we're making the assumption that the Twitter API is not changing. So all we're testing is like, if we were given this response, does the API in our uses work correctly? And one of the nice things to do to make this easier is just recording the data. So there's some really good tools in Ruby. I forget what it's called. It's like VHS or what is it? VCR. It's very, very interesting, and it basically lets you like capture a request body and a response, and just like throw it into your test suite, and it will reproduce that with certain utilities. I don't know if there's anything good in the Python world, but it's pretty easy just to capture the data. So an example of this is like, and we use this all over at this point actually. So let's say this is how the Twitter API worked, and you have to understand the internals, which goes back to the mocking is fragile. We're literally just mocking, let's say it's got a get response method, which is what comes back with the actual response, and we're just setting the return value, which means we're never actually connecting to Twitter. We're just making the assumption that it's always going to respond in the same way. So it goes back to assuming that things are not going to change on you, which generally comes out to be true. We've had a few breaking issues. Facebook likes to change their APIs with only a few days' notice. But most other things have been more or less static. And then we can make certain guarantees using smoke test. And a smoke test for us is generally like, say we have our comment form, and we'll go all the way through using Selenium, and we'll say, okay, if the user loads this page, they log in doing this, and then they post a comment, and then the comment shows up. It's a very, very high level, very slow test, but it guarantees that this behavior always works correctly. And you can do the same thing for Twitter. You can have tests that run kind of outside of your daily flow, and that just says, is the API responding the way I expect it with my interface contracts? So it goes back to testing the lifecycle of requests. And you really want to test the entirety of the lifecycle at some point, but you have to decide how important that test is. Like, we don't actually test the Twitter API. If it changes, I mean, it's a problem for us, but they make certain guarantees that their API is going to be versioned, that it's going to work correctly, and we just assume that they're a responsible company and that it works just fine. And I mentioned we use Selenium for some of this, and I want to stress the kind of here. It kind of works. It's by far the most brittle thing we've ever used. It's constantly breaking. We're constantly disabling all Selenium tests. And we've actually swapped out a bunch of Selenium tests with JavaScript like unit tests sort of, but they're integration tests, with a tool called Phantom.js, which is actually really neat if you want to test JavaScript things server-side. And we actually report results into Jenkins and whatnot with this now. And it's very nice. But Selenium, kind of a necessary evil at this point yet. Hopefully it gets better. I think there's some other alternatives coming out which will be pretty good. So anyways, those are kind of the key areas that I find suck about testing. And then it goes to don't admit defeat. So we have all these problems, and we need to solve them, and we need to get around them. So the first thing we do is we start with a goal. And this is what we did early on at Disqus. When I joined, we had a very slow test suite. It took about 40 minutes to run on, I think, our integration server. Users basically never ran the test. There were only 5 or 6 engineers at that point. But there was just not this culture for testing. So we started with a goal. And the goal began with we need testable code. Because if the code's not testable, you don't want to write tests for it. So a lot of software is hard to test, very hard to test in some situations, but it doesn't have to be that way. If you go into it with the mindset of this is how you can test things easier, things will become much, much better. So this is an example function that I ripped out of Django because I needed it for another project called Sentry, and basically all it does is serve static media out of a directory. This is not very easy to test. There are so many bits and pieces going on in a single function call that you have to do a high-level test for everything, and that means when one thing in here breaks, usually half of your test suite is breaking, which gives you an inaccurate report of what's wrong. So the easy way to solve this is to break it up. There's 3 key areas in here that I would break up. You obviously have this little chunk of code right here that's normalize the path to some extent. You do some stuff in here which generally is just returning a response based on certain things, and then down here we're just we need to return a file-like response. So you could break that into 3 functions, and then you could test each individual function, and it'd have much more accuracy. So once you've gotten testable code, whether it's breaking it up, it's abstracting out how you access the database calls, whatever it is, depending on your situation, then you actually need to write the tests. And this is, I think, one of the biggest issues we had. Why do you want to write tests? You want to write tests because you want the code to be stable. Well, how do you know that the tests are good? How do you make the tests not so painful to write where you're actually not going to hate life every time you have to deal with them? So step 1 is making it easy, right? We go back to the same example throughout this presentation pretty much. And it's this middleware that we wrote to change transactions. And this is so much easier to write than the other code. It's so much easier to understand that if somebody sees this, they're like, well, this is easy. I'll gladly add 10 more tests because it's 2 lines of code each. And it just comes down to adding helpers wherever it makes sense. So a lot of people practice dry, and I'm guilty of not doing this myself, but it was just recently we hired a Ruby developer, actually, who was crazy about OO and cleaning up all of our tests. So half of our test suite now turns into mix-ins. So it's anything that's repeated, even throughout the test suite, rather than us copy-pasting the same code, it turns into things like this. And you don't really think about it at first. You're writing production code, your non-test, the code that is not your tests, rather. And you're well, it's not that big of a deal. It doesn't have to perform well. It doesn't have to be easy to maintain. We're just going to drop this in here. It's going to test it. It's going to work, and it's fine. But really, that's not how it ends up being. And it was just something that we didn't think about for a long time. And now our tests become much cleaner when we have things like this. We also use other things. Django provides some very nice utilities. There's a query count utility, which can be nice to ensure certain behavior, how you're accessing the database. So they have I think it's assert num queries. We have a bunch of others that are assert API call or assert anything that's very common throughout our code base. And these just become part of our core test, which is we have this Disqus test thing that you see at the top, and we just threw all these assertions in there. The next thing that we got a lot of win out, I think, was creating more structure in the test suite. Sorry. And what I mean by this is we actually organized our tests much better. So Django has this pattern of packaging your tests where you put the code, which isn't terrible, but I've grown to not like it. So what we did instead is we have a test directory, which is actually pretty standard throughout other languages. And we have a one-to-one mapping outside the top-level directory, which is describing integration here, of where code lives to where the tests are. And Django has models, so we have some code that auto-discovers anything with models and deals with auto-creation. But it more or less comes down to we have the namespace, Disqus DB annotations, and all the tests live in that parallel namespace, which has a few benefits. The biggest one is you know where the tests are. Even if there's a lot of them, they're not polluting your actual code namespace, so you can actually dig into them and see them much easier. And it's much easier to detect which tests we want to run when we're changing things. In this case, if you've changed anything inside of, say, the core of DB annotations, it will run the test there. Or if you change anything inside of the core of DB, it will run all the sub-suite inside of there. And I'll talk a little bit more why that's important in a bit. And then another big thing that we are still not doing well is documenting the best practices. I was talking about mocking and like how you can do certain things. Well, we started mocking, or not mocking, we started documenting how to do things. And we have very little of this, but it's helped a lot. So in this case, we have our own URL open for specific reasons, mostly security. And in this case, this is not necessarily an obvious thing. Like, how do you mock HTTP? Well, if you're using our stuff, it's simple. You return like a file-like object from this simple call. And then we know, like, well, this is all you have to do to mock this. And it's very clear whenever you're testing HTTP how you can return a response. It's a little bit more complicated with some libraries. HTTP-lib is kind of a nightmare because of the way the call stack works. I believe URL-lib isn't too bad, but you still have to know the internal APIs to be able to mock. And at least in this case, we guarantee the internal API, which is our URL open function, which just maps to like URL-lib or something like that. So yeah, it comes down to a lot of just like helping people write tests, making the life easier. And then this may be equally important, it may be a little bit more important depending on your environment, but we had a problem getting people to care about tests. And we fixed that by running them all the time and having certain like guarantees within the company that says like if you've broken something, you have to fix it right now. Like stop what you're doing, you broke something. And more importantly, you just broke it right now. Like we tell you within a few minutes that this is broken. And we do this via automation, which is also known as continuous integration. I'll talk more about the tools a little bit later. But it's basically like we end up with something like this. We just have a build, and it's telling us we broke this very specific test. Somewhere in here it will tell you who broke it. It can automatically notify the people that broke it. And it's very easy to get started with this. And this was like the biggest thing that got test adoption going in our company was having visibility into it. We also, I was talking about how we have a JavaScript test suite now. Nobody ever like cared about the JavaScript tests until we actually put them into our integration system. As soon as that day came, like everybody's responsible for the tests. Everybody's making sure they exist. People want to write more tests because they know that the tests are automatically going to be run. If they forget about something, they're going to know right away that it's broken. So a lot of it comes down to driving it into your culture. This has been the biggest challenge. This is kind of what I see everywhere. Everybody's kind of relaxed with testing. And it's just they haven't come from an environment where testing was important. I didn't come from an environment where testing is important. It's like I joined Disqus and I immediately was breaking things like for the first 2 months because the test suite was kind of spotty. And it was terrible. It's like Disqus was already really, really big 2 years ago. And like we push a code into production that's untested, whether it was because I didn't write tests or I wrote bad tests or whatever it was, and things break. You feel bad about that. You don't want to feel bad. And so that's when I started driving testing. And I'm like, you know what? Why are we having all these problems? Why do I have to open a web browser to run to see if something's working? If you can automate things, you should automate things. So our workflow comes down to something like this. Developer makes a commit. We have a code review system in place. We require all things go through code review, which has made it much easier to get adoption for these things in. Because as soon as that comes in there, you have someone that says, oh, hey, you didn't write any tests, or the tests don't look really good for this. You can stop it right there. And then it goes into our continuous integration server. Ideally, both of those would happen at the same time. You could run the tests in parallel. Then maybe we hit a failed build, and we go back. They have to fix the commit, and it goes back through review the entire process again. Eventually, it goes to deploy. We rely on reporting. Potentially, that will go back through the entire process if something fails in here, and very quick rollback. So testing is like, it's very important to have automated tests before things happen, but it's also very important to be able to take care of things as soon as they happen. So we try to make this cycle very, very quick. It's still not ideal for us. We're breaking things up into smaller components so we can move this cycle quicker and quicker. In an ideal world, you would have this commit, go through code review, which this time is less important, but as soon as it lands, it's deployed and you know if it's broken or not. And if you can do this entire life cycle within 5 minutes of like finishing a feature and it goes out, you know immediately what's wrong because it's still in your mind. Like, you know, oh, this is blue and it's supposed to be red. Oh, I remember I changed that to blue, right? It's very obvious what's wrong in that situation. So yeah, the most important thing here, and this is actually fairly new to us, maybe 6-9 months ago, where we started enforcing code review. But it's been really great. Like, this is an example I use from time to time. And it's like whatever I'm doing, I'm adding some information to our API. And this is a really cool tool. I'll also talk about this. But it's like we have a very, I mean, some of the information kind of sucks. Like the test plan for this is to run the test, basically, which is a very common test plan for us. But it's very nice because we can get feedback. If I hadn't written any tests in here. Hopefully somebody's going to stop me from letting that in. And it comes down to like build the culture, build the power for people to reject things if it's not their own things. And then more importantly, I talked about how we go through review and then integration. You also notice up here that it says unit, and it says unit test OK and lint OK. And this comes down to like continuous testing throughout the process and different styles of testing. So if we look at that, we go back to this, the development workflow. This is kind of what the test workflow looks like. You commit it, and before the review is even uploaded, it runs a selective test suite. And I talked about how the test organization was important. We actually take a look at the diff, and we find all the files that you've changed, and we look for parallel tests, and we automatically run those before the diff gets uploaded, which is what that unit test OK represents. And a newer version of that software even like describes every single test that was run. And then it goes into CI, maybe goes to failed build. There also might be some additional styles of testing in the CI. And then we go to smoke tests, which potentially could run on a staging environment. They would still be automated. We're still kind of struggling with getting solid smoke tests in. But there's many phases of the workflow where you want different styles of testing. And then finally, we're going to dig into the tools. And there's a lot more information here. We've built a lot of things internally. We've also reused a lot of existing tools. And I think that's the most important. There's so many good tools out there. Whether they're Python or not, it doesn't really matter. You shouldn't rebuild them. Use the ones that exist unless they don't work. And if they don't work, can you help fix them? I guess that becomes a deciding factor. So the first change we made, maybe a year and a half ago, was we switched off of the standard Django test suite. And we did that because we first wanted the test folder organization and some more powerful tools. Django uses unit test by default. It has a simple custom test runner which bootstraps a database, does some other things for you, but it runs basically just like unit test. So the first thing we did was we said we needed a better test runner that had discovery and whatnot, and we chose nose. There's a few options for this. A lot of people like, is it py.test or test.py? Py.test? Okay. I'm a fan of nose because it allows us to stick with the existing constraints, and that is that we want to follow the unit test philosophy. Py.test has some other ideas for how testing should work. But either way, there are many powerful runners that can work within your existing ecosystem. So nose generally looks like this. You get a bunch of things. You can pass a ton of arguments. There's a ton of built-in plugins. In this case, we have with XUnit, which is basically required for our CI because we need XML reporting on it to actually display any kind of information. It also has this very nice thing, which I wanted to point out, which is you can drop into a PDB when there's a test failure, which is unbelievably useful. Like I said, it works with all your existing tests, which is why we chose it. We had to build a few plugins. One restricted test to unit test style cases. So it would only run tests that were inside of a unit test class. And it would also only run tests that were like test_star or something. The default patterns basically let you write test any way you want. That means you could have a file that's like testfoo.py, and inside of there you just have a def test foo or something, and you do the same reporting on it. It doesn't really matter what you do. We just wanted to stick with obvious standards, which kind of carry over from language to language. Like I said, it had XML reporting baked in, which was super good for us. It has a code coverage plugin built in. I'll talk about that in a minute. It's just integrated very heavily. It has the debugging with PDB, which is very nice. It has some built-in timings depending on how you report, but there's also there's a plugin called Pinocchio, which will let you get some more information regarding timings. And it comes down to that there's plugins for almost everything you can want to do. We've been building more. We've released a few. We have a bunch internally. They're super easy to write. It's you inherit from a class and you define a few methods based on what you want to do. And I talked about the code coverage in here. And this comes down to a tool called coverage.py. Very, very useful. We've kind of hacked around it to make it do some additional things. But in the end, it just records like what's being executed by your test suite. It basically looks like this. You run your test suite. Setup.py test is a common way to do that. You generate the HTML reports. In this case, we're only generating for a specific path, and that's probably because maybe our test command is only executing against that path, and we don't really care about the big picture at this point. And it generates an HTML file from there, which kind of looks like this. This is actually from last week, so this is a real coverage report. This powers our RESTful API service. It's not great coverage. We have 69%, but it's actually tested very well, even though the coverage is low. And it comes down to like, what do you care about in your test suite? Like things that are not tested very well in here. We have some permission stuff probably should be tested better, actually. Transformers, they're a very simple code. Views, it's like the view is, do we redirect to an image or something? It's like, oh yeah, it works. It's not going to break. We don't really care. But then if you look at like, we have an OAuth thing in here, and it's 95% coverage because it's very, very important. But this was useful for us to look at like, well, I'm changing these tests. Is there any kind of coverage in it? Or I'm changing this code, rather. Is there any kind of coverage? And it's very nice to look at. Unfortunately, there's no real good way to integrate this inside of our CI tool, which is kind of unfortunate. So we just generate HTML pages manually whenever we need them. But, and I don't think I have a picture of this, the code review tool we use, which I'll talk about in a little bit, also has integration for coverage reporting, which is kind of nice. So you can see it like within your diff. A diff is a patch. So within your patch, you can basically see like, oh, I changed this code. Does it have any test coverage based on what was already run? And then additionally, and the tool kind of looks like this, just not quite as clean. It's very simple. Like this is not covered. Green is covered. And this is one of those permissioned files I was talking about. And you can drill into every file, and it just shows the entire source and the coverage annotations. So another big thing, we built this in-house a few years back, a tool called Sentry. I assume most of you use it already. And we found that while we were breaking things all the time, they were not things that would have easily been tested. So we needed better exception reporting. And it goes down to the tests are not enough. Like even though we have the tests, data is what breaks things most of the time. Maybe like we failed to test Unicode, which we do all the time. Or something else, like somebody sending odd data that just is malformed somehow. And Sentry kind of looks like this. It's kind of hard to see. It's got a dashboard. It tells you some random information here that's kind of useful. These are all events. This is like the number of times it's happened, and they bubble up. Once you get beyond the dashboard, it's kind of the same thing. There's a bunch of filters you can apply, which are very hard to see on the screen. You can drill down by various loggers. It's got baked-in support for Python's logging module. You can change the time interval. You can say only find events that happen between like this blip of time. It also has pretty decent trend ability based on acceleration. So like if you deploy, we might pop this open and look at the last 15 minutes trends. And usually something new that's happening will show up in there, and it becomes pretty obvious. And more importantly, you can grab context for testing. My example here is not great, and it's still a little bit hard to read. But for every frame, we grab the stack locals here. And in this case, like we know there's this variable called messages, and we know it's an itertools object, which isn't very useful to us. But most things, the value will be like some odd Unicode string or something that you can take from there, throw it into a test, and instantly be able to reproduce it without having to figure out what the user was doing or talk to the user, which has become super valuable for us. And there's a lot of other neat things you can do inside of Sentry, but that's about all I'm going to dig into right now. The most important thing throughout all this was a CI solution. And we use Jenkins still. There's some things we wish it did better, and we've kind of mangled it into something it's not at this point. This picture was from Jenkins as well. This is actually IRC. We don't even use this anymore because it's too spammy. But so the biggest thing out of all this is we wanted to be able to test every commit, which we unfortunately cannot easily do in Jenkins. We have a bunch of ways we trigger builds now that is outside of Jenkins, and it says when there's a commit, trigger this build with this repository and this SHA revision for the commit, and then it will actually just run the test suite based on that. And like I talked about how our test suite used to be 40 minutes. I think it actually grew to over an hour at one point. And then we were I think at a presentation in San Francisco, and it was ImView, which I'm not entirely sure what they do. It's something with like social video games or something. And they were talking about continuous deployment. And one of the really cool things I heard them talk about was that they distributed their test suite in the sense that they had like maybe a queue, and like every single test was like spit into this queue, and you just had workers continually run those. I tried to build that. Unfortunately, there were too many things that made it hard to run on a single system, so I gave up. And then we spent 10 minutes, and we created a distributed solution inside of Jenkins, whereas I spent 3 days trying to do this in the queue. And we did that by just pipelining jobs and splitting out jobs manually. It started at first that we ran, we have a bunch of Django applications. It'll be like our API or our core comments stuff, and we just run those in parallel on different slaves. It took our test suite, I think, down to maybe 10, 15 minutes at that point, maybe even less than that, which was a big win for us because we were at an hour at that point. And we've actually gone a long ways from there. So at this point, it kind of looks like this. And this is just for our main service, which is still this monolithic app. We have a bunch of other services that are just fast because they're small, and they just run an entire test suite. So here we have, I think we have like 6 or 7 builds that run for this. And one is our JavaScript build that I was talking about. Another is a Selenium one, which never works and probably is not enabled right now. Integration was our biggest one. Like I said, we have 95% integration tests. And so what we did is we started breaking them out per app at first. And we did that manually. We just went in, we typed in all the app names in a matrix. And then one day we forgot to add an app name, so it never got tested. So as you can imagine, there were problems with this, that we were manually entering all this data. And that's unfortunate, because Jenkins is, it's not a static system, but it's not very dynamic in the sense that you can just like say, here's my tests that I want to run like programmatically. I'll get back to that in a second. We also have a unit test build, which just runs our unit tests, which takes a few seconds. And then we have a package build. Package basically creates a virtual env, does some magic on it, and then tarballs it, and we just ship that to all the servers. Ideally, what would happen is this package would come up above the Disqus web build. It would package first. Maybe it runs some tests to make sure the package is OK, and then it runs through the test suite. The reason for that is every single one of these tests has to build a virtual env. We have like 100 external requirements. Takes at least 15 to 20 minutes to build our virtual env for the main app. So it's not very fast. So that was a problem. And we still haven't solved it, but our new service architecture is doing what I talked about, where we package first, and then we test, and then we do smoke tests or throw it on stage or whatever. So going back to this, like, this made it really, really fast at first. We manually entered these. It all of a sudden distributed across all of our slaves on Jenkins, and everything was like pretty fast. And then we had the time hit where we forgot to change this because we added a new application. And that was a problem. And we couldn't find an easy way to solve it in Jenkins because we had to define this matrix ahead of time. Like, literally, we had to go in, and it has this XML configuration, which is represented in a web interface, and say, there's admin, forums, API, embed, etc. So eventually what we did is we actually took that, and there's now, so Disqus Web is a master process that triggers all these sub-builds. Before that executes right now, there's another build that's called setup or something like that. And setup, basically what it does is it recurses through the repo. It finds all of the directories in the integration location, and it creates a matrix out of those and basically updates the Jenkins configuration every single build. Surprisingly, it actually works without a problem, but it kind of sucked that we had to do that. The other thing I was talking about was code review. We use a tool called Fabricator. It was open source originally by Facebook. It's now got a couple guys working on it. Super, super useful. We tried a few various things. Our requirements were that it had very good integration with Git, that we didn't hate the interface, that we didn't hate the command line interface, and that we could figure out how to set it up. It actually hit all of these. It is PHP. You may hate on PHP, but it's very well written. And it goes back to, like, first and foremost, it was very, very well integrated. It goes through the entire workflow of our normal day. It starts looking like something, looking like this. This is just a regular commit, except there's a bunch of metadata in here. Some of this gets added automatically, like differential is a patch. This thing just, it tags it in there once you upload the review. Manifest tasks is a simple bug tracker. The reviewers are just, obviously, the usernames of the reviewers, and the other information is just random stuff that it shows up on the page. So anyways, this is just your commit message, which is also very valuable because now your commit messages don't suck. It implicitly makes them useful. And on top of this, we got an automated partial test suite. And this goes back to where we organized our tests and we knew what to test. So when we run arcdiff, arc is the command line interface for this, stands for Arcanist. It literally discovers every test that's related, or tries to, and it will just run those. This is back before we had the better testing infrastructure. But it's very nice because it will stop you from pushing this up at this point if any of those fail. It also runs linters, as you can see above, JavaScript, Python, whatever you need. It's very easy to add more. And it just uploads it to this URL and pings the people that need to review it. And the biggest thing here is the feedback loop. Like I said, this was super important to us to get testing in. And it's worked out fairly well. So like, I showed you this page already, and this is Fabricator. Below this you'll have a diff of the code, the patch, and that will show like the code coverage. It'll show where linting violations happened, because you can actually continue even if the lint fails for obvious reasons. Sometimes the linters are just broken. But it will show you all that, and it's very clear to anybody reviewing it that you skipped this process, or like you did something that you shouldn't be doing, and it becomes very obvious in this interface. The newer version, you can actually go up to the unit test grid up there, and it will actually allow you to expand and see what ran. I believe it also shows the timings in there, which was super useful. We obviously have some terrible tests when it takes half a second. But that was like very, very critical for us. On top of that, another big thing we introduced a couple years back is something called Gargoyle. And we actually use this in kind of neat ways at this point. I didn't get the time to add the picture in here, but I wanted the, was it like fuck it, ship it to production or something? This is basically useful for doing that. The interface kind of looks like this. You have a switch, you can call it whatever you want. You have some conditions. In this case, I'm saying I want it to happen for the local address, and I want it to be all users except myself. It's also disabled. You can change it to selective, which only runs these conditions, and global, which is very nice. It allows us to do a few things. First and foremost, we can silently launch features. We do this all the time. There's usually many things on Disqus that the end user will not see, and they're just bound to our admin accounts. And more importantly, I talked a little bit about real-time. This was very useful for when we were launching our new real-time platform. It allowed us to do very good load testing without any effort. And we call that dark launching. Basically what happened is we created a system which would open the connection to real-time, but it wouldn't actually use the connection. And we put that behind a switch, so we could turn it on to 10%, to 100%, whatever we needed. And we could disable it, and nobody would know the difference because it's not used yet. So that allowed us to do capacity testing while we were working on other things. The systems also fail frequently when we're doing things like this. They're not heavily tested at this point because they're still new systems. We're prototyping. We're trying to iterate quickly. Most importantly, it didn't affect anything. There's been times where we've taken down Disqus like for 5 seconds because we turned on a switch and something was broken that we hadn't tested well. And then we turn off the switch and everything's just fine. And usually no one even notices the difference, rather. So I want to stop for a second and see if anybody has any questions. There's a lot of content in here. And we have quite a bit of time yet. None? Oh.
Hi.
Hi.
Which tool do you use for linting? Because basically everything that we throw at Django bitches about a lot of things.
The question was which tool we use for linting. We use a modified version of PyFlakes. And the reason it's modified is because we wanted to be able to exclude things that are warnings that are less important. And we only wanted to know about like this variable is undefined and things. And PyFlakes works very well. There's another tool called Flake8. So we also use PEP8. We enforce PEP8 at Disqus now. And Flake8 is a modified version of PyFlakes, and I assume a modified version of PEP8, and it will just run that all in one, and it'll give you nice combined output. And that's what I would recommend looking at to start with. It would be great if we had it when we started, but...
Is this modified version of PyFlakes publicly available?
Ours is. It's probably on my GitHub, dcramer/PyFlakes. There's a bunch of other forks. Unfortunately, we haven't combined efforts yet.
Cool, thanks.
You mentioned that virtual envs take about 15 minutes to build. Have you looked into ZC build-out?
We looked at build-out initially. The reason it takes so long is because we want to guarantee a clean environment. And I believe build-out can help with that because I don't remember exactly how it works, but I think it modifies the paths in the sense that it will only include things you specify. Is that correct? So that is very nice. We've managed to make it work without doing that, especially as soon as we switch our packaging to be the first step. It's not terrible. And we do have the ability to clean up the virtual environment. Obviously, we have hacks in place to do this. But I think we just didn't use build-out at the time because it just wasn't a popular solution. No real reason. And what we have now has been in place for a long time, so we just continue using it.
Hi. Do you use branches in Git?
Do we use branches in Git? Oh, actually, I don't have slides for this, but let me talk a little bit about how our Git development process works. We started, especially before we had code review, where every single person worked out a master. That worked okay when we had 5, 7, 8 engineers, but then it eventually became you're constantly rebasing and you're constantly dealing with these issues. So at this point, the way our flow works, and especially with our review tool, it's designed to work in this very specific way. It's similar to Git flow in the sense that we create a feature branch. That feature branch ideally does one single thing. Before it lands in master, it gets squashed, so hopefully it does one thing, otherwise it becomes a mess. Developer works on feature branch, commits, I amend, some people rebase, squash, whatever, but it has to be one final commit in the end. That goes through code review, comes back, and then we just rebase master and merge that branch in. So we don't have the develop versus master philosophy like Git flow does, because for us it doesn't matter. Our master is our production. It never turns out to actually be that way, but our master is what we consider stable. And if it's not, we say it should not be in master because we're going to continually deploy this product and it has to be stable. So other than that, it's more or less like Git flow, except it's on a library, so we don't have release branches and we don't use a develop branch.
Thank you.
I'll go ahead and finish up. I don't have too much more. I seem to talk very quickly. So the last part of this is the takeaways. I talked a lot about how culture was a big deal. It was very hard for us to adopt a lot of this, and it's still a work in progress. It's getting better every day. Our test suite still has decent coverage. Maybe we have 70%, which a lot of people think is great. I'd like it to be higher. Our test suite still has a lot of holes in it. We do a lot of things with database optimization to where we have a global fixture that loads for every test, which is a problem because it creates issues with isolation and then new developers don't understand it. It made it very fast, however. And we just have lots of issues with people coming from backgrounds that are not used to testing, understanding the systems and what we've done. It's become easier, but it's definitely the biggest challenge of the company. It's not free. I don't work just on testing. I work on a lot of various products at Disqus, but I've probably spent 30% of my time at Disqus building out infrastructure and improving our tests and the way we run tests and the way we organize code and everything that comes down to like making the quality and the stability of code more important at the company. So the first is that your needs will vary. I talked a lot about unit testing versus integration testing. Integration testing is awesome for us. We made it fast. We invested the time to make it fast. But unit testing, if you do it from day one, doesn't have to be terrible. If you have a library, unit testing can work really, really well. And it just comes down to what do you need at your company? What do you value more? We use Django, so like testing the database is pretty easy for us. It has very fast tests with transactions, so we don't really worry about is that slowing us down? Do we need to test it at a lower level? Because that comes back to now we're spending more time not only writing the code because we need it to be testable, but writing the tests. And we did create some tools to make that easier. I have a slide full of links at the end of this. But it came back to what do we want out of it? What's important to us? Like, do we want to still be able to ship fast, or do we want to have like a perfect product? And you got to find the line in between there. Like I said, we release every day, at minimum once a day, but I think we have like a 15-minute deploy time if we deploy all services, which isn't ideal, but it does mean that we can release continuously throughout the day if something comes up. And that also gets easier as you break your app into smaller components. So it just goes back to identifying what you need in your company. And again, the process is very much evolving. Like we started with a very ghetto CI solution that was like red-green. It was custom. I don't even remember if it worked. And then we switched, to Jenkins because it fit our needs like well enough. It doesn't quite fit our needs now. If we keep using it, we'll see. But we started with one thing and we iterated on it, just like anything else in the code. And so it's always like, what do you need right now? What will make this better? What can I invest the time into? Again, we started with all integration tests, actually. The unit tests didn't exist until like 6 or 9 months ago. And we only have a few hundred of those at this point. And there's not too many new tests every day added to that chunk of them. And it's just because we don't need them that much. Like, we've learned that we can handle the 5-minute delay from knowing is a test or is this patch stable or is it broken. And again, there's ways you can cut that down even more without sacrificing the ease of writing those tests. And the most important is the culture. Like, the culture is very hard to adopt. I have no idea how I started this, but yeah, I came from a PHP background originally. This was probably 6 years at this point. And then we just picked up Django because it looked awesome. Had no idea what tests were at that point. My thing was, let's upload the PHP file using an SFTP drive and see if it works in production. That's how we know if it's working. Or it'd be like rename the file and test the new file and then copy it over. So it became an evolving process. And I think a lot of people come from like this like hackish world of like, let's just get stuff done, do things however we can figure out how to do things, and then we evolve that process for ourselves. And then eventually like somebody becomes so interested in it that they drive it for other people that have less of a passion about like maybe testing, but they want their code to work and they want it to work well. And they don't want to feel like embarrassed when they deploy something to production and it doesn't work. Why did it not work? Like, how could I have stopped it from getting there? And that was the biggest thing that got us to implement a lot of this, was that we wanted a very stable website, but we didn't want to have the cost of like only releasing once a week and having a QA team and all these other expenses on top of that. And then I kind of wanted to put a Nike symbol here, but I'm not sure if that would have been okay. It comes down to just doing it. Like, I would say Disqus half the time doesn't realize I'm wasting time on this, but in the end, it turns out to be very useful. And it was just because one day we decided to drive it forward. And it's a little bit of work to get it going. It's a little bit of work to change the process every time you make a big iteration. For example, when we set up Selenium for the first time, I think we spent 3 days trying to make it work. We eventually switched to a service provider. We had problems with the service provider, so we scrapped using Selenium there. Then we scrapped Selenium for like 6 months. Somebody joined the company and they're like, oh, we should have Selenium tests. And we're like, okay, good luck. They wrote those and then they worked for a week. So it becomes like, it's very heavy to add those next big steps in there. When we optimized the test suite from 15 to 5 minutes, I think we spent probably 2 or 3 days with a couple people on it. We spent a couple days, like maybe a month ago, with like 4 people on it trying to fix an intermittent failure. And every time you hit one of those things, just like in your production products, you figure out how we can prevent this in the future. For us, that intermittent failure was creating better isolation without sacrificing speed, or better reporting on why it's failing or how it's failing. And for us, that was literally adding a new build that ran in parallel to our distributed build, which is the only one we really cared about, that ran the entire test suite synchronously. So if like this test would fail because this test ran before it, we'd immediately know that that happened in this build. And it was all just, it came down to solving our own problems and scratching our own itch. And I think that's like all it takes. Like, figure out the value where it is in your company and then go from there. And that's actually all I have for slides, even though it was quite a few slides. Were there any other questions? Otherwise, I can talk a little bit more about these tools.
Hi. We are only just sort of setting up testing stuff with a Django setup, but we use Django Jenkins just to automatically set up some of the stuff. But I thought it set up coverage to generate the XML to put that into Jenkins.
So
you weren't using that? Or?
Yeah, Jenkins does have a coverage plugin, I think it is. It's called Kobatura. Yeah. Unfortunately, like, I assume you've used it, and like the output is kind of, it's very Java-like, let's say. So comparing it to the HTML representation of coverage.py, it's no match for us. It's just so much easier. Yeah, it's just literally, we wanted the product to be useful and not just available. Eventually, especially as we're doing more complex things with Jenkins, we're transitioning from Jenkins being this reporting platform to this build platform. A good example is like we have that package job as part of Jenkins, which has nothing to do with testing really, but it's more of a build thing at this point. So we're actually going to be building something on top of Jenkins. I'm confident we'll open source it, and the goal is just to make it so we have an abstract service that just fires a job in Jenkins. We can aggregate all these results, whether it's coverage.py, it's our code review process, it's the test, whatever it is, we can aggregate it in a nice simple interface that we can make just as good as that coverage.py HTML file. But that was really our main reason. And it's the same reason we also don't report linting results in there. It just comes down to like reading the console log and seeing what's wrong. Okay. But they also usually get caught before they get into CI at that point. So.
Okay, thanks.
So you said that writing tests takes up time from engineers, which is natural. It can take up quite a lot of time. Do you have any hints, tips to deal or to explain this to the non-technical people above you, and help them help convince them that this is really, really a good idea for the long term?
I don't know if I have any usable tips. I just said, at one point, I'm like, why are we deploying stuff that's broken? And it was basically a reaction to that everything was now broken on production, and we were wasting a bunch of time. I think the best way, obviously nothing that you can just reuse, but it's going in and like, if you have that case, which was ours, where you said we wasted like 3 people spent 6 hours debugging production problems. These other ops people now had to like react to their production problems and stop what they're working on. And if you can somehow make a dollar measurement there on how much time was spent versus how much time you could have just spent ahead, or that single developer could have spent ahead of time writing the test, I think that's where the big argument comes in. We have no QA people. Like, I think that's a big deal, especially for a product our size, that we can run without QA people. That's pretty cool. And we are fairly stable. And so I think arguments like that I think you do need kind of the dollar analysis to go with it, I think are the best way to sell it.
Hi. I'm just wondering if you could possibly talk a bit about your deployment process. I know it's not strictly to do with testing, but...
Yeah, so we use a tool called Fabric, which I assume most people are familiar with. If not, it's a simple Python library that allows you to execute commands remotely on servers. So basically our deploy process looks like this. We have the package step. After all the tests run, that package is now delivered to some other remote server, which acts as our hub server to pull that down from. If we were Twitter scale, I assume at this point we'd use BitTorrent, but for now we just rsync that package onto every single web node. And then when we deploy, it's literally every single server in sequence goes through it. I believe right now it downloads all the packages first, and then step 2 is that each server it iterates, and I believe it runs a simple test command. I'm not sure if this happens in all services. And then we swap out a line in the Apache config. I don't know why we do this instead of a symlink. And then it's so actually before that, rather, we have a lot of servers. We have load balancers, so we actually lower the priority first. We swap out the package on the server, and then we bring it back into the pool. And we do that one server at a time. Unfortunately, because we do not have enough capacity to do it faster than that. I feel like in an ideal world, and we've talked about this, we could have 2x capacity or 2x what we're using. And we can deploy to all those nodes, somehow warm them up very quickly, and then switch them all over at once. Obviously, that's easier if you're using like cloud-like infrastructure to where the cost of those nodes is only in there for that short amount of time. But that's where it comes to the 15-minute time for us to deploy. Is like if we have to deploy every service, it takes about 15 to 30 seconds, depending, for each each server to get deployed to and warm back up and get in the pool. But it's very standard. Even at our we have. I think the largest service, which a bunch of our services are closely tied together, unfortunately, like the comment widget is a service, our API is a service, and the Disqus.com website is a service. Unfortunately, we usually deploy all this together, which means the servers is a lot higher than it needs to be. But if we just deploy embed the comment widget or the API, there's maybe 10 to 15 servers in there, and we can get that out in 5-10 minutes. So it's not too bad at that point.
Hi, we've been using code review with Review Board, which is good but not great.
Yeah.
And we have a lot of problems with sort of the process of what it means to have reviewed something and who's reviewed it and that kind of thing. And I wonder if you have a process for, guaranteeing quality of code review.
We don't have a great process at all, honestly. We've thought about this. We haven't found a good way to solve it. But right now, it's you somehow arbitrarily assign reviewers. We usually assign more than one, not because more than one person needs to sign off, but because we want somebody to do it, and we don't really know what everybody's schedule looks like. I don't really have a great solution to solve that. We've also had issues with the quality, like what should you be doing during the review? I think that comes down to education. Like what do you need to look for? What are the key things that you're looking for in a review? When should you reject it, or when should you just say, this is good enough, but you could make this change and it would be nice? So a lot of times, like the example I showed, somebody was suggesting in it that, oh, maybe we should refactor this so it lives here and we can reuse it. Well, we didn't actually do that, whether it was a good idea or not. The code review was accepted, and it was just like a suggestion. It was good enough, but a suggestion. So some of it's come with experience. Some of the people are more familiar with doing things like that. But I think the biggest issue we've had is less quality and more about actually getting through the process. Like, when should you spend time doing it? And we haven't really solved that yet. But it's definitely we're seeing it become more and more of a problem as we grow the engineering team.
Hi. What do you think about having a full test-driven development in your workflow?
I've tried to do TDD, and I've been successful only when I didn't know the language. Unfortunately, and I don't know how everybody works, but my mind, I want to write the code first, and then I want to write the tests. That said, if there's a bug, and I have like the Sentry context or something, I'll pull that down and I'll try to write the tests first. I might look at the code first, but I'll try to write the tests first, and then it becomes more TDD-like. But I only do that when I'm like dealing with a regression, and that's mostly so I can say, well, it was actually broken using the test before I actually try to fix it. I don't think it's a bad thing. I think the culture is much harder to adopt with TDD than anything else. Because there's another company like InView that practices continuous deployment and talks about it a lot. It's I think it's called Wealthfront now, and they, I believe, are entirely TDD, and they work in the finance industry, and it's pretty impressive the stuff they're able to do in that industry. They deploy like every 5 minutes or something. It's pretty nuts. But they also are able to deploy like half of their machines at once because they have so much extra capacity for requirements. But yeah, I think it just comes down to the culture and like what feels right in your culture. We don't stop anyone from doing one specific style of testing. We try to conform to certain standards, and that's like how you write the tests or where you write the tests. But if you want to write the test before or after, that's up to you. As long as in the end it comes out to be quality code.
Yeah, thank you. Actually, I would like to ask, what do you test for? I mean, who decides the behavior which is correct for the algorithm you are writing test for?
It's kind of arbitrary. Like, code review helps with this to make sure our tests are not useless. One big thing that I probably should have mentioned is that for a long time we wrote a lot of positive tests saying like, does this work correctly in this like precise situation that we're expecting it to work in, but we didn't write any of the opposite side, like where this negative situation, does it actually like fail or fail gracefully, or does it still work? So I think a lot of like, is the test good and is what it's testing good, just comes down to code review and like how well the people reviewing the code are able to review the code, whether it's like standard practices or it's like, are they familiar with what this code is doing? Because if you're asking somebody to review your code and they've never looked at that or they have no idea how that system works, like the tests might look okay, but are they even doing anything useful? And we've had a lot of that. Like at some point I wrote a bunch of tests like when we got on this like unit test phase. It was like a month where we're like, unit tests, yes. And I wrote a bunch of tests. I mocked everything. I mocked like memcache, for example. And then all of a sudden I remembered, and by remembered I mean something failed in production, that you have a key size limit in memcache, and the mock does not like tell you that that's there. And so we were just setting long keys, and it just broke horribly. And that's kind of when we made the decision that switching like a lot of things from integration tests is not the right decision, because we want to like correctly test a lot of behavior. And those tests were reviewed. There were a lot of those tests, and everybody like was like, oh yeah, this is fine, but it still got through. And that just came down to like, I think a lot of it's trial and error, like figuring out what's the right thing to do and trying to like drive that into the culture, whether it's like just talking with your peers, having like a group of people that mentor everybody else. Really depends on the situation. But I think it all comes down to education on like what is the right way to do things.
I'd like to ask, how do you handle test data? I mean, do you use fixtures, or do you mock the database, or I don't know, factors?
So we have a few things in place. So Django provides fixtures at the application level. That was a problem for us because it had to reload every test suite. So we implemented global fixtures. one of the things, actually, before I get into that, one of the things I list up here is Django Nose. We don't use Django Nose anymore, but we use a highly modified version of this where we've like broken out a lot of components. I highly recommend looking at that. That said, I'm not sure if they implemented it, but we were trying to get global fixtures into that. And it's basically like the test suite starts, it spins up a database node, it spins up a Redis node. Actually, it doesn't spin up databases, it creates them like the standard Django thing, but it spins up a Redis instance. And so now we've got areas of isolation. And in this sense, we start the test suite before we run any tests, and we load a global fixture. And right now it's a JSON fixture. It's not ideal yet. It's a very like small fixture. It doesn't have good enough test data in there. But it loads one shared global fixture for everything. It loads that into SQL, and it loads that into Redis. And then each test always has that fixture data present. So it's just relying on that existing and relying on the test not being too absolute about what's in the fixture. And it's been another area we've invested a lot of time into. It made it very, very fast, but the isolation level issues became a problem. But it does come down to we just use fixtures. We don't mock the database hardly at all. It's too risky to mock the database many times. Like even though Django is supposed to work correctly, you could just pass like a wrong value into a filter or something that would not translate to a database value or something along those lines. Yeah, it's kind of iffy. That said, we do have a library that we open source called, I believe it's mock Django or it's Django mock. It's on GitHub somewhere. And it has some initial concepts of how you could mock the ORM and still effectively like see is it working correctly, as well as things like models and like an HTTP request. It's not quite the same as like the mock library itself, but it provides very convenient objects to use. But yeah, there's not any real good solution to any of that. It's like trade-offs either way.
Hi, did you ever use mutation testing, and what do you think about it?
What testing?
Mutation testing.
Mutation testing?
Yeah.
I'm actually not familiar with what that is.
This is testing that you have make semi-random changes in the code, like switching greater than to less than, and then trying to see if test fails actually. And it is this is a kind of method to test is your test a good quality, because if
it handles both sides of it.
If you change something like a expression in if statement, will it test it or just pass around?
Interesting. No, I haven't used that. That sounds very interesting. Like it sounds very similar to how you would potentially test like operation size. Like Netflix is very big for talking about their Chaos Monkey, I believe, stuff, which is where they just like pull servers out and see if things work. And it sounds very similar to that in the way it would test things. Like if I completely changed like this logic, does it still work? Does it fail miserably? It's interesting. I haven't done it myself. I don't know if anyone in our company is familiar with it either. But it's an interesting idea.
Was a question over there? No? No.
How do you handle testing of feature branches? Do you create in Jenkins a test suite for every feature branch and run them through?
So ideally, there's two ways, like how we handle it now and how we're going to handle it. How we handle it now is we run the selective test suite. Some people will run the full test suite because 5 minutes isn't terrible and they'll just do something else. So they'll run that in their branch. If nothing else, we hope that the selective automated test suite before the code review goes up catches the issues. It doesn't always, maybe like 10% of the time things go through and the build goes red. But it's basically after it merges into master, then CI is running. So we don't find it until it goes into master. That said, what we're going to do is when a code review goes in, immediately that will kick off a job in Jenkins that pulls down that patch, applies that patch, which potentially already fails here, and we can now report back that you need a rebase or whatever, and then runs a full suite. And then Jenkins would actually be in charge of merging that patch in when it was ready. That's our eventual goal. We haven't gotten there yet, but I think we'll get there very soon. All right. Nobody has any more questions?
Okay. Yeah. Thank you. Thank you very much, David. Just want to remind you that the coffee break is starting at 10:30 in the hall. So we need to wait a few more minutes.